Hi, we created this started guide to explain how to use the MoleNetwork application, which is a tool that supports the process of generating backbone metro core and metro aggregation segments of a network. First of all, you need to download the repository from GitHub using this link. Then to install the dependencies, execute pip install-r requirements.txt. The repository includes several files, main scripts to run the tool. To run the backbone network generator, you can use the script main.py. When starting, it will create a backbone network using the parameters provided in the script, including degree connectivity, degrees, and frequency. If the frequency is not a proportion, it will be normalized. Total number of nodes, upper limits of the distance ranges, types of nodes, for example, NCOs, RCOs, transit, and proportions. Colors to represent each type. The GUI will then show with the first tab showing the default values provided in the script. Degree Constraints tab includes the basic information required to generate the backbone model. In particular, it includes a degree distribution for the node connectivity preloaded with the default values. It can be modified using the existing controls. A distribution to define the different types of nodes in the topology. It can also be modified through the GUI. An input element with the total number of nodes that the topology should include. The algorithm to be used for generation, spectral, spring, Kamada-Kawai, spiral, or shell. The generator to be used in the process, default, dual, and region. To add a new degree value and its distribution, insert a number in the degree field and the corresponding value in the weights field. Then click the Add button located below them. The new value will appear in the list at the right side of the frame. Insert the modified values for the degrees and weights fields and select the row to be modified in the list. Then click the Update button. To remove an entry from the list, select the one you want to remove and press the Remove button. The same way we can modify node type and its proportion. To add a new type, insert a number in the Types field and the corresponding value in the Weights field, and click the Add button located below them. The new value will appear in the list at the right side of the frame. To generate a new topology from the information introduced in the Degree Constraints tab, just click the Run button at the bottom of the frame. The Graph tab shows the generated topology in the left side of the frame. The nodes are colored depending on their type and the configuration innately provided in the command line script. The distribution of links into the distance ranges provided by the user is shown in the right side of the frame. Distances are scaled up based on the maximum length provided. Notice that the Run button is available through all the tabs so the topology can be regenerated at any moment. It is possible to change the ranges and the maximum length of the links using the Change Distances button. This opens a new pop-up window where upper limits for ranges are shown and can be modified together with the maximum length value. To add a new limit, just insert a value in the left top input and press the Add button. Changes will not be saved until pressing the Save button. In this example, we split the 200-400 range into two parts, 200 to 300 and 300 to 400. If the inserted value is over the maximum existing limit, it will create a new range instead. To merge existing ranges, for example, converting back the 200 to 300 range and 300 to 400 range into 200-400, or removing the highest range, just select its upper limit and press the Remove button. Then click the Save button. To change the maximum value, modify the input field at the bottom left of the window. Click the Save button. It is possible to add and delete links from the topology using the commands in the Graph tab. If we choose one link and press Delete Link, it will be removed from the topology. It is also possible to add a link by using the two drop-down lists on top of the Add Link button. These modifications must be made carefully, as they might affect the survivability characteristics of the topology. The Grouping tab visualizes the clusters created as association of nodes that can be used later for metro network generation. By default, the application group nodes based only on the distance between them, without considering if they are connected to each other. To define the distance to be used for clustering, an epsilon parameter used in the dbScan algorithm is applied with a default value of 0.03. Clusters can have single nodes by default. The Grouping tab lets the user change these parameters by modifying the distance to be considered by increasing the epsilon parameter, and forcing to avoid clusters with single nodes by merging them even if the distance is over the specified limit, and selecting a clustering strategy that not only considers distance but also connectivity. To change the distance to be considered, just open the drop-down list and select a new value. Then click the button Search for Groups to force the clustering algorithm to run again. To force the clustering algorithm avoiding single clustered nodes and merging them to other close clusters, just mark the corresponding checkbox and click on Search for Groups to force the clustering algorithm to run again. Let's consider the Saving to File tab. This tab is used to create an Excel file for the topology and save the generated image. The Save tab only includes, at this moment, a Save to File button. When this is clicked, a file system navigation window appears. If the writing process completed without error, we can see a confirmation message. Please note that when the file exists, a message appears asking you if you want to replace it. In reality, the system will try to combine the existing nodes in the Excel file with the new ones. If it is not possible, it will abort. It will not overwrite the original Excel file, but it will overwrite the original image file if both are backbone networks. Let's take a look at the second part of the tool, main metrocore.py file for the metrocore generator GUI. To run the metrocore network generator, you can use the script main metrocore.py. When starting, it will create a standalone metrocore network using the parameters provided in the script, including the similar parameters to backbone network generator, degree connectivity, upper limits of the distance ranges, types of nodes, and colors to represent each type. Also, there are the initial names for the national nodes that will be used as reference to create the parts used by the algorithm to compose the network. The GUI is showing in the first tab the default values provided in the script, except the names that are shown in a different tab. The Metro Mesh Constraints tab of the metrocore network generator has similar functionalities as the Degree Constraints tab from the backbone generator, except that there is selection among algorithms as a Metro Mesh network is generated by default. To generate a new topology from the information introduced in the Degree Constraints tab, just click the Run button at the bottom of the frame. Let's take a look on the Source tab. This tab lets the user to choose between providing the information manually or reusing theme metro regions created by the backbone generator. In case of introducing it manually, this tab lets the user change the number and name of national nodes that will be used in the generation of the network. The Metro Core network connects regional nodes to backbone nodes. The names and number of these backbone nodes are defined in the application. By default, is using the list of nodes provided as parameters to the GUI. To add a node, just insert its name in the LEP input field and click in the Add button. To remove an element, click on the element in the list and press the Remove button. Once the names are defined, it is possible to regenerate the topology using the Run button, and it is also possible to generate the metrocore network using, as reference nodes, the ones created previously with the backbone generator. To do so, we will select the File option instead of the default Set of Nodes value. To upload the file, click Load from File button. Window will appear where it is possible to select the Excel file that was generated by the backbone generator. Once we select that file and click on Open, the list of read clusters is loaded and listed. The process also loads the drop-down list under the Select Cluster label. In this list, we can select the particular cluster and related set of nodes that will be used in the process. As an example, if we select cluster 0 from the image above, the nodes NCO1, NCO20, NCO21, NCO25, NCO33 will be taken as reference nodes for the metrocore generation process. To select the cluster, just open the drop-down list and choose the one you are interested in. By default, the metrocore network will be generated following a mesh structure using the parameters defined in the Metro Mesh Constraint tab. Let's press the Run button and check the Graph tab. that is used to represent the generated structure and print the distance ranges generated based on the information provided in the initial script. However, when the cluster is formed by just two nodes, it is also possible to ask for a generation of an n-ring structure using these two nodes as the ends instead of the default mesh. To do so, whenever a two-node cluster is selected, for example cluster 5, the checkbox for Generate Ring Structure is enabled, that it is disabled by default. When the Run button is pressed, depending on the state of this checkbox, the application will create one structure, mesh if it is unmarked, or the other, n-ring, if the checkbox is marked. The drop-down list, number of rings, defines how many rings are to be created between both end nodes, and it is only used for n-ring structures. If the n-ring structure is selected, then it will print the associated network, for example, the 4-ring structure. The Save tab is used to create an Excel file for the topology and save the generated image. The Save tab only includes, at this moment, a Save to File button. When this is clicked, the behavior is similar to the same tab in the backbone generator. Let's move on to the third part of the tool, Metro Aggregation Network Generator GUI. To run the Metro Aggregation Network Generator, you can use the script main-metroaggregation.py. When starting, it will create a standalone Metro Core network using the parameters provided in the script, similar to other parts of application. The GUI will then show with the first tab. It will let the user generate horseshoe structures for Metro aggregation models. The Source tab lets the user to select a file to load a pre-generated Metro Core network. To do so, press the Load from File button and selects the related file opening it. Then the information with all the nodes available in the file will be shown below the button, and it is also populated in the first drop-down list of the Select Source and Destination nodes. The user then expands the list and select one of the ends of the horseshoe. Once an element is selected, the second drop-down list is populated with the values of the nodes connected to the chosen one. When both ends of the horseshoe are chosen, the user can select the number of hops, links between nodes in the horseshoe. To generate the new horseshoe, click the Run button. The Graph tab shows the generated horseshoe structure, and the graph is printed as a line to simplify the representation. Saving tab creates an Excel file for the topology and save the generated image similar to the previous backbone generator. To do so, click Save to File button. Thank you for watching our MoleNetwork tutorial.